Hello guys, and welcome on my final project presentation. My project is about Tetris Game development with C++ and raylib library. I am Yannick Kuite and I am planning to graduate with my associate degree in computer science this semester. This project is a modern, fully functional recreation of the legendary Tetris game, one of the most iconic and widely recognized video game of all time. Developed in C++ using the raylib library, this version delivers a smooth, engaging gameplay experience that stays true to the original spirit of Tetris. The purpose of this project is to learn game development using C++ and the raylib library by creating the core mechanics of the classic Tetris game, such as smooth tetromino movement, intuitive rotation, collision detection, line clearing, and increasing difficulty while strengthening problem-solving skills, exploring object-oriented programming, and experiencing the satisfaction of completing a complex and rewarding challenge. What is Tetris? Tetris is a puzzle game where players arrange different shapes called tetraminos, each made up of 4 tiles. The pieces fall one by one onto a vertical grid. What about basic game rules? The goal is to arrange the pieces to form a complete horizontal line without gaps. Completed lines disappear automatically. The game ends when a new piece overlaps locked block at the top of the grid. How to play and interact. Move block, use keyboard arrow, the default left, right, down. Rotate blocks, use the up arrow to rotate clockwise. Block rotate around a central point. Restart the game after a game over, press any key to restart. Okay, you press any key to restart. Let's talk about program architecture modeling and OOP quickly. The development approach has mainly 3 components. So the first concept is divide and conquer. Strategy used to break down complexity into smaller, manageable components. Then I have object-oriented programming, adopted to structure the code clearly, simplify maintenance, and promote reuse and scalability. About the modeling, my key classes are grid, represent the main play area, 20 rows by 10 columns, store the state of each cell. Position, utilities class representing a location on the grid, row and column. Block, base class, abstract, parent class for all tetraminos, define share attributes and method. So on abstract parent class for all tetraminos, we have an ID, rotation state, movement, and rotation logic. Use it in inheritance for code reuse. Specific block classes, we have the left block, the L block, the I block, O block, S block, T block, and Z block. Inherit from block and define unique shapes and rotation behavior. We have the game class, which is the core class managing the entire game logic, hold grid, current, and next block, handle input, collision, scoring, and game state transition. The color.h and color.cpp file, dedicated file for centralized color definition, avoiding duplication, and improving readability. So I have a couple key data structure, the game grid, block representation, other important structure like raylib types. Why these choices? Today arrays for grid, map for vector for blocks, map of vector for blocks class, OOP and centralized game class. I have to move quickly because my time is not a lot. I have some key function algorithm that I've used. Then you can pause to read quickly. Uh, the part 1, the part 2, and part 3, where I'm describing how my block declaring and so on. And the user interface and score. I have a UI visual element which is defined with all the data that you can see. I've handled drawing with raylib, displaying and centering the score. I also have score update and display. I also add sound and music that you can observe in a couple seconds. The role of the role of audio using raylib audio model, playing audio, unloading audio, game integration, loading audio file, and so on. So let's proceed with the program demonstration now quickly. So I run it on Visual Studio Code since it was pretty easy for me to add my raylib library, and I also going to add this program on my GitHub repository, and I will provide a link for you if you want to check on my code deeply. Okay, so this, you can see how my game is working there. I'm going to very quickly, and you see I have game over that is showing up. I can pre-visualize the next element that is coming here. If I hit any button, my play going to restart again. You see, I have 100 points when I win. So that's a little bit it about my presentation. I want to thank here Nick Kumaris, which helped me with his GitHub repository about how to setting up raylib with Visual Studio Code. I hope that you're going to learn something new. I'm going to provide the link of my GitHub program that I drop on my repository so you can check on it. Thank you. Bye.